Hello and welcome to The Limit Does Not Exist. It's Kayla here today and we're going to work through Hibbeler Statics problems 2-17 and 2-18. Before we get started today, I do want to remind you to please like, comment, share, and subscribe to our videos so that we can continue to bring you more statics and other upper level math and science content. Alright, so before we get started today, I want to go ahead and I want to take a look at this problem that I have. It looks like I've got a little plate or something here that has three different forces acting on it. I've got F1 equal to 30 newtons, F2 is equal to 20 newtons, and F3 is equal to 50 newtons. F3 is along the positive x-axis. F1 has a 3, 4, 5 triangle, and F2 has a 20 degrees measured from the y-axis. All right. The problem 2-17 states determine the magnitude and direction of the resultant Fr, which equals F1 plus F2 plus F3 of the three forces by first finding the resultant F prime equals F1 plus F2 and then forming Fr equals F prime plus F3. Okay, so the first thing I'm going to do is I'm going to go ahead and I'm going to redraw. I'm going to redraw this problem here. So I've got X and okay, let's try this guy again. All right, so we've got the X, the positive X, and the positive Y. Let's go ahead and get our white marker. We've got F3 going along in this positive X direction here. We've got F1 here. And we've got F2 down here. And this right here is 20 degrees. And this right here is a 3, 4, 5 triangle. 4 and 5. Alrighty. So the first thing I'm going to do, because this problem, and I've already read the second problem, so I also know that the second problem needs me to have F1, F2, and F3 written in vector form. So I'm going to do that first. Before I even jump into the actual problems, I'm going to do that first. So I'm going to have F1 is equal to what? So I know that I want the X portion of this F1 force first. So I'm going to do 4 over 5 because it's the same as the cosine. Remember that cosine equals the adjacent over the hypotenuse. And the cosine of this angle here, of this angle here, will give me the X factor. So adjacent over hypotenuse would be 4 over 5. And this is going to be negative because we're going along in the negative X direction. So we have negative 4/5 times 30 newtons. And this is I hat plus, this time we're going to do 3 over 5 because remember that sine is equal to the opposite over the hypotenuse. And the opposite of this angle here is 3. So we have 3 over 5 times the magnitude of the force, which is, once again, 30. Oop. That should be 30 newtons. And that's in the J hat. And I'm going to go ahead and simplify this a little bit. So we have F1 is equal to 30 divided by 5, which is 6, and 6 times negative 4, which is negative 24. So we have negative 24 I hat plus 30 divided by 5 is 6, and so then 6 times 3 is equal to 18. So plus 18 J hat, and the units are in newtons. All right, so that's my F1. That's very important. And now let's go ahead and find F2. F2 is going to equal 20 times the sine of 20 degrees I hat. Now I know somebody's going to ask, why on earth are you doing the sine of 20 degrees? Well, remember, sine is the opposite over the hypotenuse. I want to find the opposite of this angle 20 degrees because that opposite is parallel with the x-axis, and that is what my I hat component is. So if your angle is measured from the y-axis, your sines and cosines are going to be mixed 99% of the time. All right, and this should be negative. So we have negative 20 or negative F2 sine of 20 degrees I hat, and we're going to add, and this is actually going to be negative 2 also, negative 20 cosine of 20 degrees J hat. And if I can leave it like this, or I can plug it into my handy dandy little calculator. And it's going to give me, well, shoot, I didn't write it down. So I didn't actually plug it into my handy dandy little calculator. And I'm not going to do that right now to save on time. So I'm going to have this. You can plug it into your calculator. All right, and so then we're going to go ahead and write out F3, which is just 50 I hat newtons. And there should be a newtons out here because our units on these 20s are newtons. Okay, now let's get down to the actual problems here. We have 2-17, and it says to please find FR such that you have F prime, that should be a prime, plus F3, where F prime is equal to F1 plus F2. Okay? So let's go ahead and find F prime first. F prime is going to equal, let's put our bar over there, F1, which is, let's add the x components for first, negative 24 I hat minus 20 sine 20 degrees I hat plus 18 minus 20 cosine 20 degrees J hat. And once again, our units are still in Newton. Now this one, I did go ahead and do the numbers out on. So this is going to leave us with negative 30.84 I hat plus negative 0.794 J hat. And once again, my units are still in newtons. So that's my intermediary step. There's F prime, and FR is going to equal F prime, so negative 30.84 plus F3. So plus 50, and that's in the I hat, plus negative 0.794 for F prime, and there is no J hat component for F3, so that we're just going to leave it like that, J hat, and newtons. This simplifies to be 19.2, 19.2 I hat plus negative 0.794 J hat newtons. But they don't ask us just for FR. They ask us for the magnitude and the direction. So to find the magnitude, we're going to do 19.2 quantity squared plus negative 0.794 quantity squared. And we're going to go ahead and take the square root of all of that equals FR and this is going to be approximately equal to 19.2 newtons. Now we're going to go ahead and find the direction by using theta, which equals the inverse tangent of y over x, so negative 0.794 over 19.2 gives us a degrees of 2.37 degrees. So I get the magnitude of FR to be 19.2 newtons, and I get a theta for the angle between to be 2.37 degrees, and that is going to be measured from here. All right, so now let's go ahead and let's do problem 2-18, which is written just underneath of that. Alrighty, so we've got, this time they want us to find the magnitude and direction of FR rather, such that F prime is equal to F2 plus F3, and then FR is equal to F prime plus F3. So they want us to find it such that FR is equal to F1 plus F prime, where F prime is equal to F2 plus F3. Basically what they're doing with this set of problems is they are getting you to show that addition is commutative and it doesn't matter what order you do these in. Okay? So F prime is equal to F2 plus F3. So we're going to have negative 20 sine 20 degrees plus 50 I hat plus negative 20 cosine 20 degrees j hat. And our units are still in newtons. All right. And I'm just kind of going to leave it like that because I don't really want to make that any less messy. I guess I could. We could do 43.16 I hat minus 18.79 4 j hat. And our units are still in newtons. All right. And so now we're going to find FR, and we're going to add F1. So we're going to do negative 24 plus 53.16 I hat plus 18 minus 18.794 j hat. Oop, in parentheses, our units are still in newtons. All right, and when we simplify those numbers, they become 19.16 I hat plus negative 0.794 j hat newtons. This is FR. Oh, hey, would you look at there? This FR and this FR are exactly the same. So when we go and find the magnitude, they should be the same. So the magnitude of FR is going to be 19.16 quantity squared plus negative 0.794 quantity squared square root. And that gives us 19.2 newtons for FR, for the magnitude of FR. And we're going to find theta to be the inverse tangent of negative 0.794 over 19.16, and that's going to give us 2.37 degrees, and we're measuring that in this first quadrant here. All right, and so there you have it. There are our answers for these problems. You can go ahead and box this guy in as well. If you have any questions, please don't hesitate to share them in the comments box below. Until next time, have a great day.